Hi, my name is Corey Goss, and in this video, I'll be introducing you to some of the driver tracing capabilities within our SimVision debug solution. Specifically, these are the topics we'll be covering. I'm now going to switch over to the demo. This is the same demo environment we've been using on other videos within the series. In front of you is the waveform window, and we have a failure scenario identified. If I zoom in close, we see that we have an assertion that's firing, and we notice that there's a failure that occurs at this particular time. If I place my cursor on this edge, I can actually do a driver tracing operation simply by selecting the signal and then right-clicking and saying go to cause. What this does is this will launch the source browser and take me to the exact line in which this failure scenario is occurring. So I take a look now and I see that I have an assertion. The assertion fired because when it finished, the RF pop signal was high. Now the assertion states that the RF pop should always be low whenever the RF count is equal to 0. So I now have two different signals that I could perform some tracing around. I want to understand exactly why this assertion is firing. So I could take a look and see why the RF count is set to 0, or I could try to understand why the pop signal is being set to 1. I'm going to do the latter here. And the way that I do that is simply by double-clicking on the RF pop signal within the source browser. The default operation is to perform a driver trace. And we see that this takes us to this line in the source code. Now, I want to pause to introduce a few of the features that we have just in this source browser around driver tracing. Now, first notice that down in the bottom right-hand corner, we actually have 3 drivers listed for this signal. Now, green indicates that this is the active driver at this point in time. Red indicates that these are other possible drivers, but they're not currently active right now, and I can navigate between them all simply by clicking in this bottom right-hand side. I also have a toolbar in the source browser. So this allows me to do a driver trace on any signal selected. This allows me to trace loads. This will walk me through the various drivers that are currently listed in the bottom right-hand menu. So I can go up and down and notice that the color changes. So even though I'm on an RF pop signal, we know that this isn't the driver because we have a red square. And I can navigate up and down through this list. I can also trace the previous historical step in my driver tracing operation, or go to the next step to easily move backwards through my driver tracing operation. Now, for any driver that's selected, there's a number of contributors that cause that driver to be selected. And in this case, we see that there's 3 in the if statement above. One of them is highlighted. The reason it's highlighted is because this is the most likely contributor that's causing this driver to be selected, and you'll see that it's the only one that's transitioning right now. The reason it's highlighted is because it's an indication to the user that this is where you might want to continue your driver tracing operation next. So I double-click on that signal, and this takes me to another signal in the list. We see we have an assigned statement, but again, one of them is highlighted, only one signal is transitioning. This is the most likely contributor, so I double-click on this. Now we're taken to a scalar assignment. And now we have to do a little bit more investigation. So I take a look in my source and I see that I have a number of different signals that I could explore. I could explore why any of these 2 signals in the if condition are set. I could explore potentially why this case statement is being set. Maybe I might need some guidance here though, in terms of which one I should select. I don't want to go down any dead ends. So what SimVision offers is a driver tracing sidebar. So if I click on this sidebar here, a new set of information is shown to us. Here we have a listing of all of the drivers on the WRE signal. And for the driver that I currently have selected, it'll show me all of the contributors. It also gives me probabilities. And the driver tracing solution in SimVision works on heuristics, which shows us probabilities around specific signals and how much they contribute to the selection of any particular driver. And they're ordered according to highest priority downward in this list. So if I hover over this STB is signal, you see that this is 75% probability that this is the reason why that particular driver is selected. as I move down through the list, you'll see that the gradings will get smaller. So I'm going to click on this WB-STB-IS signal. So I double click on that, and again I'm taken to another connection. So I double click on that signal, and now I find that I'm at the top level pins to my DUT. And if I look in my driver tracing sidebar, I'll see that this signal, STB-I, is connected to the P-cell 0 bit, and this is the eventual cause for my assertion firing. So I've been able to trace this all the way back. Now, one thing that I'd like to also point out is for any signal in the source browser, if you're not necessarily interested in drivers, maybe you might just want to trace signal connections through the hierarchy. We also allow that through just simply selection on a signal, right-clicking and saying follow this signal. And now we're presented with two options. We can go up or down through the hierarchy, and in this case I'm just going to jump up to the P-cell 0, and we'll see that this will take us to the exact line that's causing the assertion to fail. It's because somebody is actually driving P-cell 0 bit, which eventually propagates down to the assertion and causes the RF pop. Now if I want, I can also, any information we see in the sidebar, I can always right-click and I can say add this contributing signals out to the sidebar, and this will create a new group with the driver and any of the contributors, and it allows me to do a little bit more analysis in the waveform window. So I hope this helps out. Do check out other videos within the series.